Rebecca Lawson is Vice President of Product Marketing for GE Digital. She's been a musician, she's been a scientist, and she's been an innovator. And for the last several years at GE, been working on cybersecurity, but now on innovation in the core businesses of GE, which I will let her tell you about. Rebecca, thanks for joining us.
So if I get lost, thank you. Thank you. As Chris said, I'm from GE, General Electric, and I'm going to take a very big story and try to condense it down to about 15 minutes and give you a sense for what we've been doing at GE along the lines of innovation. And first off, there is nothing else. There is only innovation, because we are evolving and we will continue to evolve. And the reason that's kind of a funny thing to say is because I come from a company that's really old, like 130 years old, something like that. We're known in the United States as being the light bulb company, although we don't really make light bulbs anymore. This seems really loud. Does it seem loud to you all? It's okay? Okay, I feel like I'm just really loud. And we're actually known in the industrial world. So we make a lot of big machines and we sell services on those machines. We have something like 500 factories around the world, and we make turbines and jet engines and healthcare equipment and all kinds of stuff. And we've got about 300,000 employees. We're all over the world. We're not as well known in this part of the world as we would like to be. But we had a problem that started emerging, maybe 10, 15 years ago, which is that the market was just flat in all the markets and a lot of the markets that we were participating in. Think oil and gas, think energy, power generation, healthcare, industries like this. And productivity, growth rates were somewhere between 1% and 4%, being generous, which wasn't really very interesting. And so we had to really start to rethink what we were doing quite a bit. And we knew that there was obviously a lot of technology we could take advantage of. And we knew that there's a lot of data locked up in everything that we build. So like, for example, I think this is a tractor. So there's a lot of data, and we started putting in the early days. So the problem we were trying to address is, how can we grow and evolve as a company when what we were doing seemed to be so flat in terms of its growth, in terms of its trajectory? And we were successful, but just not moving. And we knew that, just like in earlier markets like media, that digitization is what really makes all the difference. So I want to talk about digitization and what that means, especially in the world of objects, in the world of things. You've probably heard about the Internet of Things. So the things that we care about at GE are really big, expensive things that are used in the production of really important stuff like energy, things like that. And so the things that we make, we call it, really important things, because most of them are involved in day-to-day money making for the organization that's using that thing. So the question is, how can we knew there's a lot of data locked in there, and we thought, we didn't know for sure, because a lot of this is just looking ahead and taking a guess, taking an educated guess. We said, if we could get the data out of this thing, if we could do that, and if we could make sense of that data, maybe we can make that a little bit more productive. Maybe we can save some money on the maintenance of that thing. Doesn't sound that interesting, right? It's kind of actually, I've been in technology all my life and only now a couple of years in industrials, and it doesn't sound that exciting, but it actually is when you step back to think about what we're doing when we say digitization, which I'll get to in a minute. So we knew that we had to solve a lot of problems that would scale and span between the different kinds of businesses that GE was in, which is one of the big disadvantages of being a large company. If any of you have been with large companies, sometimes you're trying to solve a problem for a lot of different customers, all of who are very special and have unique requirements. But I digress a little bit. We knew that what was consistent across all of our businesses is that they needed to extract data and start to understand how to better monetize the information flow from that data. So we had had early successes in putting sensors on jet airplanes, so we could start to track what was really happening on the jet engine, which, as you can imagine, is kind of important, because what we want to find out is there anything that might interrupt the operation of that jet engine? And that was one of our first entrees into this area of trying to discover, what is it that we want to know? What is it that we can know about a particular thing that's part of a mission-critical operation, which, by the way, if you take this off and it goes into repair for a couple of days, money's just wasted. Now, we know we have to do that sometimes. Of course, we have to take the equipment off, but we don't want to do that until we absolutely have to, because we want it to be productive as often as possible. So, on a one-off basis, for when we think about the Internet of Things, it's really all around us, but the industrial Internet of Things is where a lot of action is happening now, because the stakes are so high, because we've invested so much money in these big, $50 million turbines. So we really had a lot at stake. And remember what I said early on, the problem we're trying to solve is, a problem of growth. So we want to grow faster, and we knew we needed to evolve. So some interesting things happened along the way. Those are kind of our starting assumptions. And luckily, we have a chairman who really had this vision about building out, digitizing our business, going from being an industrial business to a digital industrial business. And I have to admit that when I first thought about it, I thought, well, okay, digitize this. I can visualize a CAD drawing, right? You can visualize a CAD drawing of this, and you can turn it around. It looks really cool, and you can zoom in and zoom out. So I kind of thought that that was the implication for digitization. But I've come to learn that it's a whole lot more than that. That the richness of the data that's mind you, this is a big thing. So it may or may not translate to a smaller or a consumer thing. But I would argue that we're at the kind of the bow wave of trying to figure out where the value is going to be in the next 5 years, 10 years, how we're going to grow. So what I start to realize is that if you digitize this thing and you think about it and you have good information about this from the past, so let's say we knew about this thing way back here when it came off the factory floor, right? So it's, all right, comes off the factory floor. Oops, I hope this isn't an antique. All right. So if we knew about this turbine's past, then we would probably have a lot more insight into what's going to happen in the future, right? So, but we didn't have that information 30 years ago when this was created, and that's part of the problem, is a lot of the equipment is still in production today. And so what we're really doing is we're starting at the present, and we're trying to look backwards as much as possible, but as we move forward in the present, we can start to say, what is the current condition of this object? If this object was digitized, I can look at how it's performing now. And as I move a little bit forward, more forward in the future, I can say, well, what is its condition now based on where it was back here, plus all of this information. And so it continues and continues. And so we're starting to build these things that we call digital twins to help enable a whole bunch of different data about this large physical object. Now that data today, that data can start way back here because, of course, we have modern design technology and we know exactly how this comes off the factory floor. And as we move forward in the future, we say, what's its past been, what's its current, and we can project a little bit in the future. And then as we move forward more, we have even more data in the past I can check its condition, and maybe we can hop a little bit more into the future. And what are we doing? We're looking at how to diagnose, what's the state of this very expensive machine? What is likely to happen in the future? Are we maximizing the output of this machine right now? Is there a way that we can have this one jet engine, bring it off to repair it when it really needs it, as opposed to, the canonical every 5,000 miles get your oil changed? So the more we digitize physical things, the richer we can start to interact with it. So now what we're doing is we're really connecting minds with machines, because we're taking the human, how should I say this? The human's ability to reflect on your past, what's happening now, and to think about what's coming up next. Let's see, we're having drinks in like a half an hour. That's predictable. But think about the time that's boiled into this. Now consider the fact that this guy came off the factory floor with 20 others just like it. And so if we lined all 20 of these up like here, the worst thing that you want to do is be on the same maintenance schedule, because it doesn't make sense. Any physical object is going to go through wear and tear depending on its environment, right? And so you want to be able to maximize, you want to know it so well, where we really are starting to get to know our machines really well. Of course, using a lot of technologies like machine learning and analytics and lots and lots and lots of data. And so there's a ton of technology that's going into this. But I have to tell you, what's old is now new again. Because I love some of the pictures that you showed, Vincent, of the old cars, because we're seeing this evolution happen right in our lifetime. And right now what we're seeing, because we have a financial incentive to do so, is how to really push the envelope on maximizing the value of one tractor, or 20 or 100, creating these things called digital twins. And if you haven't heard about digital twins, you will, because it's becoming a thing, so to speak. Digital twin is all of that information that allows you to have a unique view of this one machine available without knowing what the context is in advance, so that when a context occurs, you can be very specific about your actions on that thing. So, I think I've been a little long-winded, so let me just summarize a few things, especially around the idea of innovation. We are definitely following, at GE, we're following information flows. We look at how information goes from the past to the future, how it spreads across fleets of large machines, because that machine does not live on an island. It's attached to a lot of other things. So the question is, what information flows are going to be most, profitable to watch? Is it the life of that thing, or is it how this thing, this large thing, interacts with this and this and this, right? There are no islands on Earth. There are no islands. So what we're really trying to pay attention to is, how do we monetize the information that our company uniquely has? And of course that would apply to any other company. What's unique, to GE, what it is the asset. So this is precious to us because this is the business that we're in. So we're digitizing it, because that's where the more fidelity to the digitization of a large asset for us is golden. We think that's where the value is. Now, we don't know every way it's going to play out. I'm thrilled to be at GE, because we're actually moving the ball forward and experimenting. Not always getting great results, failing a lot, failing fast, but failing in the right direction, the direction of digitization and the value that comes out of that. So, thank you.
Rebecca, just am I correct that you changed the business model for charging for jet engines?
Yes.
Based on your ability to anticipate their maintenance needs?
Yes, in fact, so there are a lot of different, we did that in the early days, which
Yeah.
was to say that because we had our engines so finely tuned with our own sensors that we felt we could take a responsibility and sell the engine as a service.
Yeah.
So, and we're always looking at those business models to say that and it's a conservative company. So we try to be really conservative with our investments. But if we're managing the asset and we can influence and take full accountability for its life cycle, absolutely, because that's what we're learning to do, to take advantage of the whole life cycle. Because when we have the history, we can project the future. And that reduces risk.
Yeah. Thank you.
Yeah.
Yeah.
Okay.